going to take a look at number 2. We're going to use our Xbox method. So we're going to multiply our A value times our C value. So 2 times negative 15 is negative 30. And on the bottom, our B value, there's an understood 1, so our B value is 1. So we're looking for factor pairs of negative 30 that have a sum of positive 1. We could use positive 6 and negative 5. 6 times negative 5 is negative 30, and 6 plus negative 5 equals positive 1. So we're going to split the 1x into 6x minus 5x. That is still equivalent to 1x. We're undoing combining like terms. We keep the 2x squared, and we keep the minus 15. So we now have our 4 terms, so we are now going to box it. So we're going to use 2x squared, 6x, negative 5x, and negative 15. On the top row, the GCF is 2 and x, and on the bottom row, the GCF is negative 5. In the first column, the GCF is x, and the second column, the GCF is positive 3. So in factored form, our equation is 2x minus 5 times x plus 3 equals 0. We are solving, so we have to set each binomial equal to 0 and solve for x. We're saying that this product of 2x minus 5 times x plus 3 equals 0. So either our 2x minus 5 has to equal 0, or our x plus 3 has to equal 0. Now to solve the first equation, we're going to add 5 on each side. That equals 0. Negative 5 plus 5 is 0, so we're left with 2x equals 0 plus 5 is positive 5. And then to finish solving for x, we're going to divide both sides by 2. I'm okay with leaving this as a fraction, 5 over 2, or that's equivalent to 2.5. It's not a very pretty 5. Okay, and then the next one, we have to solve the equation x plus 3 equals 0. So you'll subtract 3 on both sides, and you get the solution x equals negative 3. So for number 2, your solutions are 5 over 2, or 2.5, and negative 3. Okay, so for the next set, we are asked to solve using the graphing calculator. Remember, in order to solve using calculator or factoring, we need the equation in standard form, ax squared plus bx plus c equals 0. So when I look at number 3, I notice the equation equals 28. So I'm going to have to solve by subtracting 28 on both sides of the equation. You're only going to combine like terms, so you're going to keep your 6x squared, and then negative 2 minus 28 we can combine to minus 30, and 28 minus 28 equals 0. So if you're using the graphing calculator, you're going to go on to the y equals, and you're going to type the equation in at y1. So we're going to type that 6x squared minus 30. On line 1, and on line 2, make sure you type in the 0. You need to remember that the x-intercepts are your solutions. The x-intercepts are your solutions. So you're going to do intersection. So if you look at your graph, you will see that the parabola crosses the x-axis. Okay, I have a line, so let me check my... Oh, I left off the square, so hold on just a second. That's why I got a linear equation. Okay, so here's the graph. So we definitely have 2 solutions. We have 2 intersections. So we're going to go to second, trace 5. And if you hit the up arrow key on your calculator, that puts the cursor on the x-axis. Now move the cursor to the left side, the left intersection, and press enter 3 times. So you will find one solution is negative 2.23. The instructions tell us to round to the nearest tenth. So one solution is going to be x equals negative 2 2/10. And now we're going to go to the right side. So we're going to repeat the steps. Second, trace 5 for intersect. Hit the up arrow key. Now toggle over to the right side intersection and press enter, enter, enter. And you will find this intersection is at positive 2, 2. Remember, when we have the positive and negative of the same number, we can simplify this and write this as plus or minus 2.2. If you want to write it out individually, that's fine also. Okay, so if you take a look at number 4, you're going to see that it's not in standard form. The equation equals positive 4, so we're going to subtract 4 on both sides of the equation. We're going to combine like terms, so this simplifies in standard form to x squared. 20 minus 4 is plus 16, and 4 minus 4 gives us our 0. So we're trying to see, when does x squared plus 16 equal 0? So we're going to go to the graphing calculator, and on line 1 we're going to input x squared plus 16, and on line 2, since we're trying to see when the equation equals 0, we're going to put y equals 0. And we're going to hit graph, and nothing appears. So what we're going to do, guys, is we're going to zoom out. We're going to have to zoom out on this problem. In order to zoom out, you hit the zoom key. So go to zoom, and you're going to choose option 3. And then once it takes you back to your graph, you press enter. And once you press enter, the graph will actually zoom out, and you can now see the parabola. Does this parabola intersect the x-axis? No, it does not. So this is an example of no solution. There are no x-intercepts, so this quadratic has no solution. If you tried to factor this, you would see that this quadratic is prime. Remember, you can only factor if it's difference of two perfect squares. This was the sum of two perfect squares. 6. Okay, we're going to take a look at number 6. Here we're given the option to solve by factoring or graphing calculator. Again, you need to make sure the equation is in standard form. This time we have our x squared, our x, and our constant, and the equation does equal 0. So we're in good shape there. We're going to go to the graphing calculator. I'm going to do the calculator first, and then I can show factoring. We have 3x squared minus 11x minus 4, and on line 2 we have our 0. So we're going to go to zoom 6, because on the last problem I did zoom my window out. So let's do zoom 6 to get the calculator window back to the standard. And we have two intersections. So remember, where the parabola, the U-shaped curve, intersects the x-axis, those are your two solutions. So we're going to do second, trace, and then 5. So second, trace 5, and then move the cursor to one of your intersections. I like to start on the left side, and as long as you're close to the left side, it's going to find it. Press enter 3 times. So one solution is at negative 0.3 repeating. Now, it would actually be better to convert this to a fraction since it's a repeating decimal. The instructions does not, actually it says we can round to the nearest tenth. So on the test, I would accept negative 0.3 since that is the nearest tenth if we round. But that's also equivalent to negative 1/3. So negative 1/3 or negative 0.3. Okay, we still need to find the second x-intercept, so we're going to repeat second, trace 5. We're going to move the cursor to the right intersection, and once you're close, press enter 3 times. So our second solution is positive 4. So the solutions are negative 3/10 and positive 4, or negative 1/3 and positive 4. Okay, in the next set it says you can solve by any method, so we're going to take a look at number 7. Make sure the equation is in standard form, and it is. We have our x squared, our constant, and the equation does equal 0. So we're going to go to y equals, on line 1 you're going to type in the equation. So you're going to type in 5x squared minus 45, and on line 2 you should have y2 equals 0. Okay, we're going to hit graph to see if we can see the intersections, and we can. There are two intersections. So we're going to do second, trace 5, hit the up arrow key to find the cursor, and now move over to the left intersection. Once you're there, press enter 3 times. So one solution for x is negative 3. Now we're going to repeat. Second, trace 5, hit the up arrow key, move over to the right side intersection. And once you're close, press enter 3 times. You will see that it's also a positive 3. So we could simplify this and write this as the solution is plus or minus 3. Okay, we're going to jump down and take a look at number 11. It says 20 more than the square of a number is 12 times the number. So the unknown is number. I'm just going to use x to represent the number as I write the equation. Remember, 20 more than, that is a turnaround word, so you're actually going to do the square of the number first and then add 20. So that's going to be x squared plus 20 more. Here's your keyword is, so we're going to write equals 12 times the number, so 12x. So this is the starting equation. We now need to get the equation into standard form. So we need to subtract 12x from each side. And that negative 12x, we're just going to put that term right in between our x squared and our constant of 20. So on the left side, the equation becomes x squared minus 12x plus 20 equals 0. And we are going to use our graphing calculators to solve. So we're going to go to y equals. We're going to type the equation in. So x squared minus 12x plus 20. Left out the 2, there we go. And then 0 beside of y2. I'm going to take a look at the graph. Now I noticed that one of my intersections is on that far right side, and it's probably not going to calculate. So remember, you can stretch your graph to the right by increasing the x maximum. So if you go to window, let's just make our x maximum 20 instead of 10 so we can see the entire intersection. Once you've adjusted, actually I changed the wrong one. I changed the y maximum. I meant to change the x maximum to 20. So check your window range on your calculators and make sure it matches what I have. And now we're going to hit graph. So now we can see the intersection clearly on the right and the left. So we're ready to do intersection. So second trace 5. Again, that up arrow key will put the cursor where you can see it. And we'll move to the left side first. Press enter 3 times. So we found one of the numbers equals 2. Now if we move the cursor to the right side, second trace 5. I think I messed up. I need to see. We'll see if it'll find it. And then enter, enter, enter. You will find the second number is at positive 10. So the two numbers are 2 and 10. Okay, we're going to take a look at number 12. I've written the axis of symmetry equation on the board to remind you, in order to find the axis of symmetry, you need to find the opposite of b and divide by 2 times a. So in the equation, a is your coefficient of x squared, so this a value equals 1, b equals 4. So to calculate your axis of symmetry, you're going to say the opposite of 4 divided by 2 times 1, that's 2. And negative 4 divided by 2 equals negative 2. So your axis of symmetry is x equals negative 2. That's also going to be the central point in your table of values. Now I prefer to use a table that has 5 rows. This table has 6. So I'm actually just going to eliminate the last row so we have symmetry. So now on your graphing calculator, you can type the equation in at y equals. And we can go to the table of values to fill in our table. So the equation is x squared plus 4x plus 5. And then hit second graph. We know negative 2 is going to be the vertex. So we need 2 values less than negative 2. So that's going to be negative 3 and negative 4. And 2 numbers larger than negative 2 would be negative 1 and 0. So in your table, you're looking at when x equals negative 4, y equals 5. When x equals negative 3, y equals 2. Your vertex is at negative 2, 1. So I'm going to write that down real quick while I'm thinking about it. When x equals -1, y equals 2. And when x equals 0, y equals 5. And again, you should see the symmetry in the table. See how you have your 2, 2, and your 5, 5. That should always form around the vertex. Okay, we're going to go over to the graph and plot those 5 points. So we're going to go left 4 and up 5. I'm going to move left 3 and up 2. Left 2, up 1. And since that's the vertex, we should see the graph beginning to turn and increase again. Now we're going to go left 1, up 2, and 0, 5. So now you're able to sketch your parabola. It's also a good habit to draw your axis of symmetry. Remember, that's going to be this vertical line. It crosses the x-axis at -2, and it also passes through the vertex point. The other thing it asks is, does this open up or down? You should say that the graph is opening upwards and your vertex is at the bottom of the graph, so it is a minimum. This one does not ask for solutions or roots, but if they did ask for the zeros or the roots, you would say no solution, because notice the parabola does not intersect the x-axis. Okay, let's take a look at number 16. It says a ball is thrown upward. Its height, h in feet above the ground after t seconds, is h equals -16 t squared plus 32t. We are asked to find the maximum height. So we're going to get the equation entered into the calculator. -16 x squared plus 32t. So we'll type in 32x. This is an application problem, so we'll need to do zoom 0. I'll make some notes. Okay, after you've set up zoom 0, we're going to go to window and change your x minimum to -1, and also change your y minimum to -1. And that's going to allow us to focus on quadrant 1 of the graph. Okay, we'll go ahead and hit graph and see how this looks. Now I see that the room at the top of the graph is very minimal, so let's extend the y maximum. So I'm going to go back to the y. Really, the x maximum, we could drop this down. I'm going to just change that back to 10, and I'm going to change my y maximum to 30 just to give some extra space. So I'll make a note of that. I changed my x max back to 10. I increase my y max to 30 to provide more space at the top of the graph. Okay, so the question asks us to find the maximum. So the maximum on the calculator, you're going to go to second, trace. And that is option 4. And they're asking you to set the left boundary. So you're going to have to hit the left arrow key to get the cursor to the vertex. Once you find the cursor, place it at the vertex. And they're wanting us to set a boundary to the left of the vertex. So move the cursor to the left side just a little bit and press enter. Now we're going to move the cursor to the right side, enter, and then one more time press enter. So you will find the maximum is at the point 116. Remember, 1 is the x value is time, the y coordinate is height. In this problem, they're asking for the maximum height, so the answer is 16. So that is answer choice C. Okay, let's take a look at number 18. It says an object is dropped from a tall building. Suppose the distance traveled is given by the formula d equals 16t squared, where d represents the distance in feet and t represents time in seconds. About how long does it take the object to fall 800 feet? Now it does say show your work, but I'm okay with you using your graphing calculator. So if you go to y equals, go ahead and type the equation 16x squared in at y1. The easiest way to find the answer is going to be to look at the table of values. So if you go to second graph, our answer choices are at 2 seconds, 3 seconds, 5 seconds, or 7 seconds. So at 2 seconds, the object has only fallen 64 feet. At 3 seconds, the object has fallen 144 feet. By 5 seconds, we're at 400 feet. And by 7 seconds, we're at 784 feet. So 7 seconds is going to get us to the closest height of 800 feet. Notice the problem does say the word about. So we're going to choose option D, 7 seconds.